Hi, this is a video for ARC 325 to go over the NAAB compliance portfolio pages that we're doing for our final portfolio. I've created basic sample layouts for all three. This is for the building performance, the HVAC, and the daylighting and electric lighting. I'm going to go over each of these, two of them in this video, and the daylighting in another. First thing I want to do is review quickly or briefly how zones work, because for the building performance sheet you need to run simulations in Climate Studio. So if I have these two zones, or these two volumes, extrusions, and I want to turn them into zones, I'm just going to accept the defaults. I'm in the Climate Studio thermal analysis workflow. I now have two zones. Right, and they're named here. I could name them 1 and 2. If we open one of these zones, what I did here, the default, at least in my screen or my version, is to have a window to wall ratio setting so that you can automatically add windows. So it's set to 0.4. I could change this to 0.8, and it will adjust the size of the glazing. So we're going to start with that. If I look inside any of these zones, I'll see, and I click through them, I can see facade with window, facade with window, facade with window, exterior floor, and roof. So the simulation knows by the context and the way we're putting these volumes into the model how to consider these surfaces. And so if we look at the exterior floor, we'll see it's green, and that's been defined as the ground. We look here in ground boundaries, they're there. That's the program saying, oh, I think that's the ground because this is where your construction plane is. If I were to lift that up, it would make it air. In other words, it would not be ground anymore. So you need to be conscious of that. You need to have a ground or understand where your building is sitting. The roof, though, is automatically determined. It's facing up, and so it knows that has a different. And all these are doing is it's saying, okay, there's a different relationship to the outside world. If I have a north-facing facade and north-facing and a south-facing facade, they will have different thermal properties or different thermal interactions with the outside air, right? Same thing with the roof and with the ground. So we need to understand them differently, and that's what the model's doing. Next thing I want to do is just show if I now pull these together. One thing changes here. I now have a partition. So you see this is a partition. And the way a partition works in the model is if I have these two set to the same thermal properties for each zone, and they have the same number of people in them, then no heat will transfer through that wall. And it just becomes a single zone. That's one way to look at it. The point is, though, you must have your zone. All your building is, some of you guys have complex forms. A zone is just a box of air, and all the boxes of air have to touch. They have to be coplanar. If they're not, that's going to screw up your model. And you need to build these slowly if you have a complex model, and just try them. Build one zone, see if it works, add another zone, and slowly build. And if you have a problem, then you'll know where it is. I guess this is a point to say, if you do have, if I have a curved surface, in my project, that will not run as a thermal zone. I mean, if I cap this, it could be it can be I can make this a solid, obviously, and it could work for daylighting, for example, but it won't work as a thermal zone, and I won't get into why. But what you'd have to do is create something that was close to it. So you could come in and draw. That's because I got a good snap on, I guess. Whatever, the point is I could be as detailed as I wanted to and make this sort of similar in shape, and make something that had almost the same volume and that had surfaces facing the sun in the same way as the actual design. So you have to simplify, and there's fancier ways we could do that, but we're not going to worry about that in this class. We could talk about it next semester. Okay, let's see what else. If I want to, and you probably are going to want to, I wouldn't probably use these preset window to wall ratios. So if you put them at 0, the preset windows go away. If I want to add glazing, it's not a problem. Uh, it just has to be coplanar with the zones. In other words, it's on the same plane. You'll see that when I add that here, you should have already done this one. I'm just trying to review. The problem here when I add this is going to be, you see it turns red on the outline, which means it's not working. And that's because we're going across two zones. And I think that could make sense, right? If this had a different number of people in it and it needed different heating and cooling, or had a different facing, then this window, this glazing, is going to have different properties. So I can't, if I take this edge and pull it to the other side of the zone, it fixes the problem. So I could then copy this and put it over here, and have two pieces of glazing. They could be right up to the edge of the zone, so they could look the same. But that's a problem you'll run into. The final thing is that we can add shading. So if it's this entry here. Now that's shading. That will then, I don't even need to add a material to it. That will block the sun in the model. Okay, so let's go to the facsimile of the assignment here. I'm using the gem charrette that we did at the beginning of the project, talking about shading. In the thermal model, you don't want to use a ton of shading, especially for the context, because it just takes too much number crunching and it'll slow your computer down. So here's my site context, and the point here that I want to make is that if I there's a lot of buildings around here, but then I just did some studies. Like I went to I was looking at it in winter, which is probably the time when you get the most shadows. But anyway, I did a study of it, and I determined that really the only facades that were shading the building, shading my site, were these few here. And so I turned those into shading surfaces for my my model. So that would be smart if you want to use your site to shade your thermal analysis model. Then find out which surfaces are actually shading the site and use those, and that'll work. Or you can just not use them, but there's especially for glazing, like windows. Like this is a south-facing gym. This building right here is definitely going to have a big effect on these windows. Okay, so then let's just go and talk about the actual model. If I go back and look at the simulation, well, we talked about curves. So in this case, I added 5 zones, and let's look at the. Actually, this is so these pages kind of should be designed together. The thing you want to do for HVAC, and this is important because it's much simpler than it could be if you don't listen to this. You need to define zones for the entire project. So here I've defined these 5 zones, and we want you to create some kind of table that defines what's different about the zones. So I have a gym, a mechanical locker, corridor, lobby, and office. I define them as being different based on their occupancy, which I looked up in the code. But basically the idea being that you have different numbers of people in different spaces, different activity levels, and so you'll have different HVAC demands. And so then I organized my zones. I said that my gym's going to have a variable air volume HVAC system on the court and the spectators as one, because it's just it's all one big space. But I'm going to have subzones, so really 2 zones in there. One that will be able to send a different temperature to the spectators than to the court. For the corridor, I'm just going to use passive solely heating and cooling. There's really no people load in there. Anyway, etc. So I've defined these zones for the whole project, but then all I'm going to I'm going to choose one zone, or you could have a group of zones. Like if you had a bunch of offices or practice rooms or something, you could design for them. And I'm going to design a system only for my gym. So let's go back to the building performance. We're talking about the gym is what we will actually use for the design, but now let's get a building performance for the entire project. And so what we've done here is giving you a spreadsheet that I've updated and simplified. But if you've already used this, it doesn't matter. There's a few things I changed. Uh, we're really just trying to get a comparison. So all you need to do is there's two runs here. One I'm calling baseline, the other New York City Energy Conservation Code, and I've given you all the settings you need. And these, so the first two runs you're going to do will be essentially automated. And let's remind ourselves how we do that. What I've done and what I really suggest you do is you go to this is the library. Let me close it out again. This is the template library in the Thermal Analysis Workflow and Climate Studio. Just pick any one you want and copy it. It really doesn't matter, but you could pick one that you think is similar to yours, so you don't have to change as much. Oh, by the way, at least in my version, I have to pull that out so I can get the scroll wheel. So I've just I selected some template that existed, and then if you click down here, you can copy it. And then you can rename it, and you have so I have, for example, here NAAB baseline that I made, and then once I've made that, I can edit it, and I put all the settings in there that I have in this spreadsheet. Right. So that's the first thing I would do is I would create. Remember that we have two divisions for the settings in the passive portion of the thermal simulation. We have what are called zone space use settings, and that's this first one. And then we also have zone construction, and I have a baseline for that also. And in here I have all of the settings from the construction envelope side. You should have already done this, but just if you have questions about how to, these are just sections, and you can add things to them. You can make your own. You can find there's tons of these in here, so that you can just find ones that meet the requirements that we've set. You're basically just editing them to get to the R values that are specified. And really, it's not even editing; it's probably just finding them. But I made my own. Okay, so then I created space use templates for both, and construction templates for the let's see, the baseline and the energy code for both of these, right? So that's this one. I'm sorry, this one and this one. And then I created zones and named them, and then by the way, you can ignore these names here. That's for something I'll show you in a minute. But if I select these and edit, here is the actually, this is good because I'm going to go and change these. Okay, I'll say this right now. So if I come to here, you don't need to use this, but I can set up zone colors, and this is what I did for. This is what's in the page here. You see. I just went ahead and set the colors here. Clearly, I could have set those in Rhino, but this is something you can do when you're optimizing. Is you can go and find templates that you think are relevant to your space use and apply them. So, like for example, I just made these up because I was looking for colors. But if I wanted to define this corridor, and as a specific, I wanted to find a corridor that I thought would have settings that were useful to me, I could go look for corridors in the templates and apply it to that specific zone. What I'm going to do instead is I'm just going to go re-edit these. So if I select them all, and I selected my space use template, I'm going to go to my library here, go to any building type. This is the way, at least in my version, it's the only way I can get the ones that I made myself. I'm going to choose the space use baseline, say OK. OK. And then if I select again, I can also change and select the baseline template. So now this is set up for the baseline. These are all gray because I am selecting preview space instead of preview model geometry. Okay, now this would be set up for and then also I would need to make sure that my windows were what I wanted. So to do that, I'm going to expand everything. This is a little bit, I don't want to get too much in the weeds. I'm trying to make this very basic, but um, if I want to edit everything, I can open it up, select everything, and I can now edit. If I select this edit tab for quarter, I can go in and edit all my zones. The only problem is that's going to change all the names to one name, so I don't really want to do that. Um, so if I'm editing windows, what's I think for my purposes, because it's a pretty simple model, I'm just going to come select all the windows. For larger models, that's harder to do, and there's other ways of doing this there that we could talk about if anybody has questions. So now I've selected all the windows. I'm going to edit them and change the window type to, if I click on, I know that I want to, let's see, I just want default, I think it's called. Yeah, default glazing. It's just essentially really bad. And I say, okay, now that all that glazing is going to be set to that default. Okay, so then I run the simulation. And let's see, my first results then, I'm calling it 1960s baseline. So let's just talk about what we're doing here. I intentionally set this up to where the first sim is pretty bad. Now it's bad in a realistic way. There are many buildings in New York City. You may live in a building that's built like this. It's basically just like I always call it 1960s. I'm not sure quite why I picked that decade, but you know, no insulation. It's all concrete. Like the Guggenheim Museum is always what I bring up because it's a wonderful project, but it's just built at a different time. Simple mechanical systems, not built airtight. So I set a bunch of settings that will make sure that we have a pretty bad performing building, but it's not unrealistic. And so that's this first one that I ran. One thing I forgot is that we have to make sure. So if I'm here in the workflows, so what we did already was, I'm going to collapse these just so not so, is we set all our zones and windows. Now I'm going to make sure that my mechanical system is set, and it was set to something different because I was editing this earlier. I want you to set your all zones to the same VAV, and the VAV system is this one here, and it's just you should use the default settings. Okay, and if you look in the spreadsheet, that's what it says. Use the VAV single duct system, keeping the presets. And if we look at the presets, what are they? We have, I don't have them in here. I think I'll have to go back and change this to what it was. It's a boiler with 0.8. I think natural gas is fine. I think I used to tell you guys to switch it to coal. You've got a chiller. I think it has a 2.2 COP rating. Anyway, just leave it, whatever the presets are when you open that, and then you run the simulation. And so we'll see. I ran this, and I got. Always go and look at the energy flows chart because that's what I want you comparing. And if we look here in my page, that's what I've got here. Is I'm comparing 3 runs. And now, again, this looks like a lot of work, but this is a table we're giving you. All you're going to do is add in this bottom row, and we're giving you the settings for these first 2 runs. Okay, so we ran this, and it's got an EUI. So what's our goal here? The game is we're trying to get this EUI, energy use intensity, that's in kilobituses per square foot, but it's just the amount of energy we're using per square foot. We want to get that down. Right now it's very high, and we can see why. We're in the energy flows chart. People is pretty high. That's interesting, right? That's just the heat from people. By the way, just this chart, in case you haven't learned it yet, it's called an energy balance chart. The middle is 0. We're divided into months, and we're showing what each of these different components of the building, what its energy use gains or losses, gains above the 0, losses below. And so you'll see that like the envelope in the winter, we're losing heat. Makes sense, right? Because it's cold outside, so we're losing heat to the outside. People are always going to be gaining heat because we're little heaters, and so even in the summer when we don't want it, we're putting heat into the building. Lights are the yellow; they're adding heat. because lights give off heat. And so what happens is we have a bunch of passive things like this is air infiltration is the purple. The big green here is envelope. We have different pieces of equipment here, people, lights. Um, and so we create a balance. Like right now, we have more in January, we have more losses. And so we're going to need to balance this out. We're going to have the heat. That's what the red is. In the summer, we have more gains, like the windows are gaining, and we have less gains outside from our envelope, and so we have to cool. So that's what's going on in this chart. So all we're seeing, and again, this is just you've put in those values, you push the button, it should work. If it doesn't work, there's something wrong with your model. If it's really bad, you could get to where you just decided that you were going to only run a model on the part of the building that you're designing the HVAC for. That would be sort of defensible. That's not what I want my section to do, but I'm saying we have to get this to work. So if there's an issue, you can always talk to me. I'm kind of the resident tech on this, or if your professor's not available or maybe isn't as versed in this, or you should learn to troubleshoot, and you can always try to simplify if you need to. Okay, anyway, so then the next thing I do is I went and set all my zones to the other template that I just showed you, which is going to have these settings in it for the New York City Energy Code, Energy Conservation Code. I ran that. I actually ran two different versions of it. I ran one where just the space in the envelope, and we can see that we have a drastic improvement between 468 to 120. And you'll see we're heading toward this 9. Now, you may not have this set correctly. This is a baseline value that's comparing our building to something that would be a similar building built to code, or maybe even built to energy code, so something pretty good. So we're trying to get here we were ridiculous, way outside of the range of this one. Now we're kind of getting in within the range, and don't worry about that number. I'm just letting you know why it's there. The second number, by the way, too, is carbon, operational carbon. If we're talking about climate change, carbon is the big metric. So, and carbon is a function partly of energy use. Well, it comes from burning fossil fuels. So the more energy we use that are fossil fuel based, the higher our carbon footprint. Because this is operational carbon. This is not embodied. This is carbon associated with heating, cooling, and plug loads of the building. Anyway, so we improved quite a bit, and you'll see, like, one thing I know that I lowered the amount of people in the space. We could talk about why I did that. Infiltration is down in those settings. We have a much better envelope, and the glaze, but I haven't changed the glazing yet. So right now we can see that the windows are the darker green. We have a lot of gains in the summer that we would rather not have. But then I ran this again with glazing that is in line with the energy code, and we see that these got much smaller and my EUI got smaller. So that's the game here. We're just looking at these values and seeing what it is we can reduce. Up to here now is just simply putting in these values and running to get the first two simulation outputs. The only thing you have to do yourself at this point is just now try to optimize from here. And so there's a couple things, there's lots of things we can do. But so what I did next was I improved the infiltration level. Now that's something you can't just arbitrarily do. I know about this, and so I actually cut it in half. You'll see that goes down a lot. I improved the glazing package, so I made it have a very low U value, and I think I lowered the solar heat gain coefficient. Anyway, so I did some things like that and was able to lower my side EUI further. I kind of felt like that was the most I could do with passive things, with considering the envelope and the windows, and I didn't write. And by the way, this whole time, I don't have it showing here, but I have, this shading is on for all of these simulations. This that I talked about at the beginning. Okay. But then next I decided to optimize the HVAC system, and that's something you could try. The way we do that is I come to my HVAC tab, and I can bring in. I don't want you using the ideal air load unless that's something I can talk about individually with people. That's kind of the default for schematic design in this Climate Studio. We're trying to use actual systems, and these are the three the options that are here. I think this is a good moment to bring this up. If I go to actually this is in the, I'll do it here. This is in the spreadsheet. Climate Studio has a good help page, and if you look at, so I'm going to type in VAV. They have nice graphics of the VAV, the DOAS with FCU, and the DOAS with VRF systems, and they also talk about the settings. So I would definitely check out the settings in Climate Studio that you would change to optimize these. So remember, FCU is fan coil units. Oops. If you go there, we have the FCU and the VRF. So fan coil unit, I won't talk about this. You should know about this from class, but they're very similar. Okay. So what I'm saying though is that then I did some optimization of the VAV system first, and let me just show you what you can do. And see, this is where I optimized it. I changed from a boiler to an air source heat pump, which is basically just always going to be more efficient if you can find one that's large enough to meet your loads, and it's more efficient because we have this we're moving heat, not creating it, and so our coefficient of performance is always going to be higher. Something you should know from class. And so a couple simple optimizations like that haven't made a big difference. So I added to my VAV systems, I added heat pumps, and that took me much further down. And you'll notice here, though, that the actual chart doesn't change, and that's because we have the same heating and cooling loads. We're just delivering them more efficiently with that low COP system. Then I changed to a VRF system, which is a little bit more efficient. So I got down to this level. There's one other step that I took. I'll talk about it in another video about daylighting. And so you'll see. So here's my point. I'm better at this than you are probably. I know more about it, so mine's more complicated. We're not expecting you guys to do something super complicated. But we gave you this, and all you're doing is then looking at this chart for the New York City Energy Conservation Code run and find something to improve it, and call that your optimization. Now, you can go as deep into it as you want to, but that's all you have to do is just make it better. You're trying to get a lower side UI than you had here, and then come in here and put in whatever the settings were that you used for all these. Pretty simple. I know there's always going to be problems, but I'm saying conceptually it's pretty simple. This chart, I just want to show you where that is available here. If I click on different, so I'm going to click on my first, so if I hit Control, I can select these separately. I'm going to select these three and hit this button here. See the little chart button? That will generate this comparison chart, and I can export it. So that's where I got this chart in this page of the spreadsheet. Okay, so that's this one. You need to do those things and then write a narrative explaining what you did here. We basically have this one done now because we said we already did this, and it's based on, we're using the same zones that we used in our, the same geometry at least. It may not be the same zones because you can define yours. How should I put this? You could make, in your thermal model, you can make every single room be a zone, and if you give it the same settings, it makes it just like one big zone. Whereas what we're saying here is that these are actually, if we were really had an engineer who was designing this, that these would be have different requirements for the HVAC system, and that's what we're defining here. Then we're picking one zone, and I just sketched it in. And I think that's fine, at least for me. I think it's even better, really, than you spending a bunch of time trying to get line weights right and making it look exactly like the thing that we gave you in a slide. But I have a floor plan showing a simple layout of supplies and returns. I have a section and I have an axon, all showing the same system. Remember, you have to, and I have my source of heat and cool, which is this heat pump on the roof. I have fresh air. I have distribution, which is these ducts, and I have energy recovery ventilation, which is this ERV right here. I have everything that that's required in the assignment that was delivered weeks ago. Okay, so that is it for those 2 pages. So that's building performance and environmental control systems. I'm going to do a separate video for day lighting and electric lighting. Let me know if you have any questions.